Hello and welcome to your mod spotlight on Infernal Robotics version 0.19.2 for Kerbal Space Program 0.25. Now this mod is by Circuit and it primarily adds robotic parts that can be used to change the shape of your vessel. And I'll go over this in a little bit, but first I want to take a look at what some of the parts actually do. So now that we're in the VAB, let's start off by talking about the UI. Now if you have the toolbar installed, then you'll have a toolbar button wherever you have it set. But I'm just going to be using the regular Kerbal Space Program buttons, and you'll find it down here, IR, meaning Infernal Robotics. So when you left click on that, it'll highlight, but nothing shows up. This is because you first need to attach a couple of parts, or at least one part. So I'm going to attach the first part, called the adjustable rail. And what you're going to get is this window that says Servo Configuration. Now, group names, of course, are identifiers, so this one is Group 1. The servo name is whatever you want to call this part, so if this has a purpose, such as being the arm of some kind of robotic crane you create, then you can just call it the arm. And of course, these are identifiers, they don't have any physical effect on the way these parts work. Let's talk about the next buttons because there is a lot to this UI. Move. Move is a new feature actually added in the 0.19 update of Infernal Robotics, and this allows the parts to translate or move, rotate, whatever they do inside of the VAB. So you can see that I am able to translate this part inside the VAB. And if I add, say, another part of the same kind, and of course if they're both in the same group, then I will be able to activate them both at the same time. So you can see them both translating and just kind of going out there. Something to note about this moving is that if you change a part's shape, as this is a changed shape from their default shape, which would be this, then if I push launch, these parts will remain in this state. They will remain partially translated. So just to let you know that. Now I'm going to move them back all the way and get rid of this one for now. Now I do want to make a note is if you have any other part, it will move with this part. So inside the VAB you can change the shape of your vessel. Now let's actually add this one back for demonstrative purposes. Now if you have more than one part, which very likely you will on a ship with a lot of robotic pieces, you can add new groups. So let's add a new group and it'll just be called new group 2. In the second rail we don't want it to be in the same group, so we have a couple ways of moving it. Now we can push this down arrow all the way on the right and it will move down to the next group, and if we add a third group and we push the down arrow, then it will go to the third group. And of course the up arrow will move it up. And since we don't need the third group, we'll just remove that with the button that says remove. So rotate basically rotates the object on a 45 degrees around the node of attachment. So as you can see, this one rotates 45 degrees around how it's attached, because of course it's attached on its bottom node from here. So if we attach this one that way and rotate it, then it rotates the same way. If I push rotate, this one rotates around the point, so it still is rotating 45 degrees, but it's rotating differently. So just keep in mind they don't all rotate the same. So another method of moving them to different groups other than this arrow is these three lines right here. They allow you to drag and drop the parts. Of course, you should wait until you see this yellow line indicating that it's going to move. Because if the yellow line isn't there and you release the mouse click, then nothing will happen. But just click and hold until you move it to the next group, and of course you can change its group. Now these brackets on the left side of the name are the defining parameters. Now for this particular object, the adjustable rail, its translation is from 0, which is its current state, to 2 meters, which would be the state where it's fully extended. So this is 2 meters distance that it has gained. But what I was stating on before is if we set this 1 to 1 and click save, then it can only translate 1 meter. So as you can see, I'm clicking for it to move, but it won't go anywhere. And of course, if we set it to 2 and push save, then we can move it out to 2 meters. One last thing to talk about are the keys. These are just movement keys. So if I were to set this to O and this to P, that means this arrow, when I pushed O on my keyboard while this vessel was launched, this arrow would activate. And if I pushed P while this vessel was launched, this one would activate. So P would extend this particular robotic part, the adjustable rail, and O would retract it. And of course you can see the number of how far it's translated with a nice decimal point value right there. Every single part in Infernal Robotics comes in a variety of sizes, from anywhere from 3 sizes to, I want to say, over 10 on the telescopic piston, because it's got variants A, B, and C, each in 3 different sizes. Now this size changing is from TweakScale, which is required in the mod, and of course everything will be in the description. And under the case of the gantry rail, you have the smallest, which is the 4th scaled down piece. If you take something such as the adjustable rail, then you have large, medium, small, but you do not have smallest. You only have 3 sets. But since the gantry rail's large is so large, it has a 4th, which is smallest. So some parts have 4 scales, other parts have 3. I've brought out the adjustable rail again because it only translates in one direction, whereas the gantry rail translates in 2. So, one thing I'm going to show down here are not these, I'll show these out on the launch pad. Now, electrical state to electric charge per second is the estimated power draw. Now, if you open up here, the group would also tell you the estimated power draw inside the UI. So as you can see, it's 2 electric charge per second for one rail, and now it's 4. And if I take the second one and reduce its size, it's going to draw less electric charge because of how big the part is. And of course, if we grab something like the gantry rail, then it's going to take 4 electric charge for its large size, whereas the adjustable rail only takes 2. So this does draw electric charge as of a recent update, so don't think that you can move these for free. And it only draws electric charge while it's active, so while you're moving it, it starts draining electric charge. When the part isn't moving, then it will not use any power. So out on the VAB, things are a little bit different. The Infernal Robotics part, or without the toolbar, it'll be on the top right, but with the toolbar wherever you have those models or those buttons. Now when you click on it, you will get the servo controller. Now this is just what it was inside the VAB, where we can translate the part. And as you can see, it translates up to a maximum of 2 meters, and it can translate back. Now the middle button resets it to its normal setting, its state that it was launched with. So if we click the middle button, nothing happens. If we translate it out and click the middle button, it'll reset to its natural state, and it won't go past it. And as you can see, we're using 2 electric charge per second, and 2 electric charge per second, or 2 electric charge per second. Whenever it moves, we're using power. Even when we're holding down the button and it's not moving, we are still drawing electric charge. Keep that in mind. Now this number over here is the speed setting for the group. So currently it's at 1. I'm going to boost it up to 5. And you're going to notice a huge change in the speed of this part's movement. As you can see, now it moves 5 times faster. So what are some of the settings of the adjustable rail? Well, the minimum translation distance is the first setting. This is the minimum distance that it can be. And it's currently set to 0.5, but its translation is at 0, or the animation of its translation is at 0. So if we tap on that, it will jump. So it will jump to wherever its translation is, and if we try to move it to the left, it won't go, and if we try to move it to the center, it will not go anywhere. Because the minimum it can go to the left or to its origin point, which, like I said, is this knob here, is 0.5 meters. Likewise, if we set its maximum translation to 1.5, then it can only go to 1.5 translation and no further. Unless, of course, we up it, then we can move it further. Or we lower this one, then of course we can bring it back even more. Okay, so next on the list is step increment. Now, this doesn't actually affect the part at all. This affects your ability to change the part's settings. So if we set it to 1, then you can see the max translate we can do is either 0, 1, or 2. The minimum translate is either 0, 1, or 2. The step that it travels is by 1. If we tone it down to 0.1, then you can see now we have 1.4, 1.5, 1.6, and 7, and so forth. It goes by step increments of 0.1. And 0.01, you can see now we can get even more precise increments. So this is a tool to help you edit the translation amounts. Now if you get them set to uneven values, such as this, 0.37 and 1.44, then you can go back to step increments of 1 and it will reset into the 0.1 settings field. Also, the step increment only affects the top 2 values. It has no effect on the bottom 2 values. So if I set it to being 1, this one will still move by 0.01. And if I set it to 0.01, it will still move by 0.1, not 0.01. So these two down here are just set to standard values. They're not affected by the step increment. So, coarse speed and fine speed. What do they mean? Well, the coarse speed is basically this part's specific speed. Let me reset these so we have the part to stop jumping around. Now you can see it moves at 1. Now remember how I set this to 5 and it increased the speed? Well, let's set the coarse speed up to 5. Does the speed look familiar? The coarse speed is this part's specific movement speed. The fine speed is basically after it. So if I had the settings set to this, coarse speed 4.2, fine speed 0.07, then this part's movement speed is 4.27. Or if I set this to 3, now its speed is 3.07. So that is what it means. Also, you can set the fine speed to negative values, which means this part's speed is 2.96, or 3 minus 0.4. And of course, if I set this thing to, let's say 3 flat, and I set this to 3 as well, then its movement speed is going to be the same as 9. So you can see how fast it moves. And now if I were to set this to 9 and this to 1, it's approximately the same. So basically, this number multiplied by the coarse speed plus the fine speed is this part's speed. Of course, coarse speed only affects this one part, where this number affects the entire group. And no matter how fast the part moves, there is no change in electric charge consumption. Now, invert axis does what you would assume. It changes the orientation of the arrows. So now the part moves differently, but the middle button still brings it to the origin. So that's what the middle button does, is it will always bring it to the origin regardless if the axis is inverted or not. And engage lock will do what you expect. It locks the part, meaning this part can no longer move no matter what you do. So that's the adjustable rail. The other parts will be much quicker because I've kind of gone over the basics on what all of this does. So this daunting button called Edit, you're probably wondering what it means. Let's click it and find out. Well, we have the servo group editor again, the same window that we had in the VAB. It's exactly the same. So, since we've already gone over it, there's no need to. However, this is an ideal opportunity to show you the keys, O and P. So, this one, once we unlock our part, this one's O, this one's P. O, P, O, P. One quick thing I forgot to mention is inside the VAB, if you right-click on the specific part and choose the option to show the position editor, then you can translate the part by units of 1 right here, or constantly, just as you can translate the part using the arrows on the servo configuration window. So there's more than one option for testing the movement of the parts. Back out on the launchpad, we have the docking washer standard. Now this part rotates. Of course it consumes some electric charge, but it will freely rotate. And I'm just going to speed it up. And as you can see, I can hold down this one direction arrow and have it spin indefinitely. So even though you can see the min and max rotate have -360 and max of 360, those have no effect on this part. So changing them doesn't really do anything, because the part will indefinitely rotate. Of course, coarse speed and fine speed do have an effect on the part, and currently it's rotating too fast for friction to rotate it alone, so it's rotating the command module down below, as you can see. Now we've already gone over everything else about it, so I'm not going to go over all of this again, but you do have rotate limits. So I just said they're useless. Well, they're only useless if you leave it standard. You can just select this, rotate limits on, and suddenly it doesn't rotate infinitely. It does have restrictions. So this is the docking washer standard. Now, you cannot force this part to move with engines, so if you stick an engine on these and start firing it, this part will not rotate. So let's look at the gantry rail. Now, the gantry rail basically translates like the previous part. So as you can see, it goes over to the left, and it'll translate over to the right. And if you push the center button, it'll move directly to the middle. Now, minimum translate is -2, and the max is 2. So it will go -2, and it will go +2. And of course, we can set these boundaries if we want to. Now, the gantry rail variant works slightly differently. It's identical to the regular gantry rail, except the parts translate through it. Meaning, instead of the original one where the black attachment node moves across the actual rail, the rail moves through the attachment node. So you can see I have this little structural piece there attached to the actual rail and not this piece. Now these do have nodes on this end and on this end, so you can attach them to either end as it goes through the black centerpiece. Then you can translate two parts, but keeping them the same distance from each other whilst moving them. Here I have the closed powered hinge and the open powered hinge. Now minimum rotate is 0 and max is 180, which are just the degrees that they can go by. And of course everything else is the same for the settings. Now what these parts do is they basically fold. Now this one is 180 degrees rotated, and this one is 180 degrees rotated. And now they're reverted back to 0. So these are just two different variants that of course allow you to start either closed or start open. Another couple of parts is the hydraulic cylinder and the telescopic piston. Both of these parts just extend in one direction outward and retract, except the piston is surface attach only and the hydraulic cylinder is radial attach only and actually goes inside of the part that it's been attached to. Now the other two parts are the powered hinge and the powered hinge 90 degrees offset. These two parts, of course, just will rotate 90 degrees. Of course, this one starts bent 90 degrees, and ultimately have a 180 degree rotational field of view, which of course you can set and limit to your desire. Basically, they work as pivotable joints. So the last few parts are the rotatrons. Now this is the smaller variant. There is a larger Mark II variant that I'm not going to show because it's the exact same thing. Now this part rotates, just like the previous one. And of course, if you leave the rotation limits off, it will rotate endlessly in the direction. Now the difference between it and the docking washer is it's not flat and it's not nearly as large. The very last legacy piece that I'll be showing is the VTOL Rotor Mark I, which works just like the other rotatrons, except that it's already on this axis, this kind of bent degree axis. So it surface attaches from this flat sheet of metal here, and it rotates 90 degrees to that surface attachment. So it's great for VTOLs, since you can point it down and you can rotate it forward and backward. Now, one thing I want to point out about the rotatrons is that if you have a firing engine, you can still rotate it. So even though this engine is burning, I'm able to rotate this part, and of course it changes the thrust vector, at least until things break. So you can rotate these parts with firing engines, which is very crucial information when trying to build VTOLs. Circuit, the mod author of Infernal Robotics, has stated on the forum page that these parts, these models, will take over the original models at some point. He hasn't specified when, but these new models, as you can see here, are done by Zodius Infuser, who has done a very good job at kind of giving them a really unique look. And as you can see, this is the same part as this one is supposed to be, except it has its kind of its own robotic unique look. Now, the Rework pack has a few differences in what kind of parts you can get. For example, this joint pivotron has a wider angle. It can bend 120 degrees in one direction instead of only 90. Now, another unique part that isn't part of the legacy pack is this joint pivotron, which is uncontrolled. Meaning, if I were to set this part here and then, say, add some weight to this one side, this would fall over, and I would have no influence on it. As well as there being some other unique pieces, such as this one, and other parts such as this, which folds out to be this part, which adds some unique styles. So these new reworked parts kind of have their own look and their own animations and way they transform. As well as this is actually part of a separate pack. It's not just the IR Reworked Models. This is part of the Athlete pack, where it adds a whole bunch of these joints. These foldatrons, which have their own unique attachment rules and looks, like this one will twist, for example. Now, even further, Zodius Infuser, who has made all of these parts, has created this, which if you have Kerbal attachment system installed, is a magnet, and it has its own lights, which you can use for picking up parts through the use of a magnet by attaching them from, of course, all of your robotic parts. It's good for creating a robotic arm. Now, along with those, you also have these nice adapters, which have their own unique style. As you can see, just some structural pieces that do not have robotic function, but have aesthetic purpose. So how about I show you a couple of neat vessels you can make using some of these robotic parts. So what I've got here is a neat little thing that fits into a stack that actually turns out to be a lander in itself. So, as you can see, it just unfolds. Once I deploy the gears, you can see that it just kind of lands and floats up like this. Now, an incredible benefit to this design is that if it finds itself fallen over, it's not very hard to fix, seeing as how it's got a very wide base that the legs will just come out and, well, correct it. So now it's sitting upright again, even though it was previously just on its side. So here I have another very interesting contraption. As you can see, this works just like any normal rover for the most part. It can steer left and right and go forward and backwards. Now what's different about it is I have these hinges. So as you can see, I can actually rotate the wheels sideways and drive sideways and turn, and even in the middle of driving sideways I can actually turn the wheels, and now I'm going forward again. Or I can turn them the other way while accelerating, mind you, and change my direction, my velocity vector, just while I'm going. And of course, turn back, and it's surprisingly stable. So what I've got here is a neat little space plane, and of course I have these two rotatrons, which are right here, bound to a couple of keys. So basically what they're doing is when I push W, they go up, and when I push S, they go down. Now, in order for this idea to work, you need Ferrum Aerospace installed. So these swept wings with Ferrum Aerospace are controlling how this thing descends. So watch the orientation of the wing. You can see I'm ascending. I'm going to hit S and lower it. Now my nose is lowering, and it's lowering too much, so I'm moving it up and trying to stabilize myself. And too much of in a dive. So here we are again with this setup. And of course, because Ferrum Aerospace is installed, is the only reason this is actually working. That I can use these swept wings to control the way I'm ascending. And you can actually create an entire vessel that's controlled this way. So I just want to disable torque again to kind of try and show this some. And I can disable SAS as well, although it's very difficult to control, as you can see. Anyhow, as I lose control of this particular plane, I do encourage you to download these parts and try these things, because you can create a plane. I've created larger ones with some of the B9 parts that are more stable, since there's a lot more drag involved with larger craft, and having something such as these swept wings change doesn't affect it too much. But this has been your mod spotlight over Infernal Robotics version 1.9.2. I encourage you to go download and install it and try out these contraptions yourself. This is PTT GRW signing out.